I'm going to do a review of the Predator Inverter 8750 generator. I was on the fence with which one I wanted to buy. This one, as you can see, is an open frame. It means you can see the motor. It is also louder than the Predator 9500 watt generator. Now keep in mind that this 8750 is the maximum. You will not be able to run it at that. This is the surge. This generator here, its running wattage is 7,000 watts. The enclosed version is 9,500 watts surge and 7,600 watts running. If you do the math on the enclosed version, you can get a full 30 amps on each leg. This one here, you can see it's 58 amps. So this would be 29 amps per leg. And for those of you who don't understand electricity per leg, there's two hots on here. That would give you 29 amps on each side, giving you the 240 volts. So if you have a well pump at home, you'll need a 240 volts to run it. Otherwise, most everything in your home will be 120 volts, unless of course you want to power an air conditioning unit. That is not my situation. My situation here was the well pump. I used to run the home on a 3,500 watt generator capable of 240 volts. And when the well pump would kick in, while the well pump is on a 15 amp breaker, it runs at 5 amps. But because it's an inductive load, it has a high surge to get that pump to go, and literally would almost shut that generator down. So I needed something a little bit more reliable. Cost is always a factor in anything that you do. The previous generators that I've used to run my home were Champion. I've had them 13 years. I've had very good luck with them. As long as you drain the gas from the carburetor by shutting off the fuel and letting it run down, you should really never have a problem. So these Predator generators have received great reviews. The 9,500 watt version, and then this open frame. It's on the fence. It's about $1,000 difference between the two. This one's about $1,200. The other one's $2,200, give or take a couple. And I was like, well, we're just going to be using this for emergency power, and is it worth the $1,000? So the enclosed version is rated at 67 decibels, and that would be at 23 feet. This one's rated at 75 decibels. I think really what saves this one is the eco mode. Not sure if that's trademarked because they actually use different letters on here. Electronic, some sort of electronic control. ESC throttle. So it allows the motor to run down to about 2,400 RPMs as opposed to about 3,600 RPMs. So, I mean, it's not that bad. Again, it's emergency power. If you're running a generator, more than likely your neighbors are running a generator too. Now, to keep these exercised, anytime I use power outside, I run the generators. So, why did I choose the Predator as opposed to the Champion? The Champion, part number 100520, it's a very similar looking generator, similar specifications. The price was similar. This one here has a 5.8 gallon tank, and it'll run 15 hours on 25% load, and that's an industry standard. 25% load is the rating for the inverter style generators. Meanwhile, your synchronous generators their rating comes from a 50% load. So 15 hours as opposed to the 4 gallon on the Champion, and that gives you about 10 hours. So I wanted something to make sure that you'd make it through the night. Say like at 6 p.m. you did a fill up, and then you'd be good till like 8 or 9 in the morning. So let me just go over the generator. This is your fuel valve. And it's got the handle for moving the generator around. This guy is heavy, about 165 pounds, so you're not throwing this in the back of a pickup truck easily. So you can wheel it in and out of the garage. It's got the pull start in case the battery goes down. This one here comes with a lithium-ion battery. I've seen in some other videos there's a question of whether this battery charges on here or not. It does. They recommend running this generator every 3 months. That would recharge the battery. When I bought the generator, the battery was about 13.1, 13.2 volts, and what was running was at 13.6 volts. So from left to right, you got the eco throttle, which I always leave on. I've already done some testing and some high surge loads, and the generator handled it fine. So in my opinion, I don't think it's necessary to run it in the off position or even just wasting fuel. And then you have the starter, so you have off and the on position, and then if I was to push up, it would engage the starter. You have the choke, and then each of the circuit breakers. This one is for the USB and 12 volt connection here. So you got a 12 volt connection under here, so that's protected by this circuit breaker here. So if it goes, you just push it in to reset it. And then it's got 2 USB charging ports. Honestly, I almost find it hard pressed that I would use the USBs outside. It's such a big motor. Anyway, has an AC reset rated at 30 amps, and then this is supposed to be a circuit breaker under here. So down, which will disconnect the power to the outlets here, and then back up. The thing is, like, if you really don't look at this, it's hard to tell the position of the switch in here, but up and it's on. You have the output indicator, overload alarm. There's no audible alarm. It's just a red flashing light. It turns green when it's running on the top, and then the low oil alarm. Here's your 4-prong connector. This would go from here to the home. That's your ground. That's your common. This is one of the 120 volt legs, the other 120 volt leg. So if you would measure voltage from here to here, it would be 120, from here to here it would be 120, and then from across here it would be 240. And then you have 2 20 amp outlets. Okay, this would be off of one leg, and this would be off the other leg. Underneath the generator, you can see the inverter. The only thing I don't like about the inverter and its position, it is in the direct line of the cooling fins on the motor. However, its position would allow mice to build a nest, and they could potentially chew the wires. The most important part of this generator is the carbon monoxide detector built in. If for some reason you are running this in an area that does not have a lot of fresh air and carbon monoxide builds up in the area, it'll shut the generator down. Now, I did hear somewhere that if the wind was blowing the right direction, now the exhaust pipe is on the other side of the generator, but if the exhaust was continually blowing in the direction of the detector, it will shut the generator down. What's nice with using a inverter that makes a clean sine wave, a normal sine wave, is it's very much like the power that comes in your home from the street. the open synchronous generators, typically are what people would call dirty power. I've scoped the other generator that I have here, and the waveform is jagged. I've used it to power my home before, I've not had any issues. What I did notice is the fluorescent lights and the LED lights will have this like a 60 cycle flicker to them. When testing it on the home, testing this generator on the home, there were no flickers. I had also performed a couple of tests where I would start up high inductive load appliances, and there was no apparent dip in the power in the residence. I'm going to start the generator. I'm going to conduct a couple of tests. I'm going to demonstrate the max amp draw of a couple of appliances. They're all inductive loads. Inductive loads require 2 to 3 times more than the rated run to start them. And I'm going to do this with the generator set in eco mode. I'm using extension cords to take me away from the generator because the microphone on the phone does not do it justice, and I want to make sure that you can hear me. Oh, here's the digital display. Missed this part here. The first part that shows up shows the letter U. It's supposed to be a V, and it'll show the voltage. When I start it, you'll see the voltage climb up until it hits 240. When you hit the button one time, it'll show the frequency, which says 59 hertz. If you hit the button again, it'll show the overall run time, which I'm at 2 hours. And if you hit the button again, it'll show you the run time for this cycle. And when I do start the generator, I'll demonstrate that by hitting the buttons. That's the voltage. That's the frequency. That's the overall runtime. We're at 2 hours. And then this is the runtime for this cycle. Each of these tests will be done on a large shop vac, an air compressor, circular saw, and a power washer. So this is for the air compressor. I'm going to set this up to max. It's going to give you the inrush current. You can see right now we're at 0 amps. I'm going to do this twice. One's going to show the max amps to start it, and then the other one's going to show you the running amps. So 21.5 amps to start the air compressor. Here we are at 0 amps. Now I'm going to show you the running amps. About 9.2 running amps. And that's with the generator set to eco mode. Next will be the shop vac. We're going to do the max starting amps. As you see, it's 35.7 amps just to start the vacuum. Now I'll show you the running amps. So about 11 amps to run the vacuum. So you can see the starting amp shows about 3 times. Now we're going to do the circular saw. Here's the max. almost 34 amps. Now, I'm going to show you the running amps on the circular saw. Keep in mind that the result that's given, the saw is not cutting any wood, so it's basically going to be unloaded. So the amps basically is just the saw free spinning. If you were to be cutting wood with it, the more you bind the saw, the more amperage it's going to require to keep it turning. Just under 6 amps. Next will be the electric power washer. This is the max amps to start it. So 29 amps. And here's the running amps. So just about 13 amps. Alright, so what does all of this mean? Well, the only reason why I bought this is because we're on a well pump. I have a very large well tank. Once the pump has filled the tank, I have some time. I don't need to run something so large to keep the house powered. I can get 15 hours on about 6 gallons of gas, and basically just keep the food fresh in the refrigerators. I have 2 refrigerators and a freezer, and of course the well pump. The rules have always been that when we're on emergency power, the family is only allowed to run one major appliance. I know some people will say, well, I'm just going to turn on a couple of breakers, just the ones we need. Now, don't do that. Turn everything on. When I say on, I mean the circuit breaker panel. Manage your power usage in the home. So one major appliance. So what can that be? The microwave. Don't make a pot of coffee while you're microwaving something. If you make a pot of coffee, don't microwave something. If you're using a toaster oven, don't run another appliance. You want to vacuum the floor, then don't use the other appliances. You can manage that in the home. Again, it's emergency power. We use window units for our air conditioning. So keep in mind that what I had demonstrated today in this video are the extremes. Our microwave might come close to what a 20 amp circuit might be. And that's basically what you're left with, is you have 30 amps on each leg. If you know how your circuit breaker, your outlets in your house, how they're arranged, and if you know clearly that, all right, well, I plug my vacuum in this outlet over here, that another outlet in the residence, maybe on another leg, you really won't know that unless you meter the stuff and figure that out. Because you can, in essence, use 2 larger appliances with this generator if you knew what leg was being pulled from. But again, emergency power, rather than trying to figure that out, we just tell the family, listen, one major appliance. And as this thing just sits outside and idles, it'll give whatever you need. The motor will spin up as fast as it needs to provide that power. And again, this is all done with the eco mode switch on, and you can see that there was no delay in starting any of the equipment that I demonstrated today. This is the outlet that will get plugged into the generator. Again, where my finger is, this is ground, and directly across from it is what you call the common. Okay, the ground is the one with the hook on it Directly across from it is the common. And then if we go from common to one leg is 120 volts. Common to the other leg is 120 volts. And then from this hot leg to this hot leg is 240 volts. This will go into this inlet here, which goes into the home. And this is my breaker panel. Everything is well mapped. This is my interlock. I cannot turn this on until I turn the main off. I turn the main off, slide the interlock up, and I turn the generator feed on. All right, so each of the breakers that are tied here represents one leg each, rated at 30 amps. Keep in mind that the generator is capable of 29 amps per leg. So, how does this work? This is on one leg. This is on the opposite leg. This is on one leg. So if you were to do X, Y, X, Y, this would be X, this would be Y, this would be X. And so these are on the same leg. Every other one's on the same leg. Same leg, same leg, same leg. The opposing ones, these would be on the same leg. Again, every other one would be on the same leg all the way up. Okay? And that's how you get your 240 volt appliances. So here's a double breaker. So one leg, another leg. If you measure the voltage across here, that's your 240 volts. Okay? If you were to measure, and that's across here, this doesn't involve the common wire. Your 120 volts from here to the common wire, which is on a bus bar inside the box, is 120 volts. Okay? So if you were running, let's see if I can find the kitchen one. See, the problem with these older houses is they used one circuit to power like the whole kitchen because people didn't have the appliances that we use today. Same thing with your second floor. We literally have two circuits that power the entire second floor. So the dishwasher's got a heating element in it. So you're going to run the dishwasher. You have to make sure that whatever is on a similar circuit, so it would be every other one, that you don't run something that's larger. So again, if you run the dishwasher, don't run another appliance. The washing machine does not have a heating circuit in it. The dryer, will this generator run a dryer? Well, technically yes, because the dryer is serviced by a 30 amp breaker. But you're going to be using roughly 22 to 25 amps of 240 volt power. So if you were to split that into 110 power, that would be about 48 amps or so, and the generator is rated at 58 amps total. Okay, so I would not recommend using the dryer. Basically the generator is going to be running at full bore to keep up with it. It's just wasting fuel. In times of emergency power, just go ahead and hang the clothes up. So I hope that the information here helps you out in deciding which generator you would choose to power your home in emergency situations. Subscribe and leave any comments and I'll respond back.